Let's play a number game. Ready? What do these look like to you? 2 to the power 3, 5 to the power minus 2, and 4 to the power 1 half. Yep, they're all exponents, tiny numbers with big power. Exponents help us express repeated multiplication, shrink down really small numbers, and even work with roots. But here's the real question. Do these cool shortcuts work when the base is a real number, like a fraction or a decimal? Stick with me, because in this lesson, we are diving into the laws of exponents for real numbers and how to use them like a pro. Let's quickly break down what an exponent really means. If I say 2 to the power 3, I'm actually saying 2 into 2 into 2, which equals 8. So, the exponent simply tells us how many times to multiply the base by itself. But wait, that's just the beginning. Exponents can also be 0, like 7 to the power 0, negative, like 5 to the power minus 2, or even fractions, like 9 to the power 1 half. And yes, they all follow certain rules and patterns. That's where exponent laws come in. Now let's unlock the 5 golden laws of exponents. They work for all positive real numbers and rational exponents. Law 1. Product rule: just add the powers when the base is the same. Law 2. Power of a power: you multiply the exponents when one power is raised to another. Law 3. Negative exponent: a negative exponent flips the number. Law 4. Quotient rule: just subtract the powers if the base is the same. Law 5. Power of a product: distribute the exponent to both numbers in the bracket. Easy, right? These rules make solving problems way faster. Let's put these laws to work with some quick examples. Example 1. What's 2 to the power 3 multiplied with 2 to the power 2? Use the product rule. Just add the exponents. That's 2 to the power 5, which equals 32. Example 2. What about 5 to the power 2 into 3? That's a power of a power. Multiply the exponents, 5 to the power 6, and that gives you 15,625. Example 3. Now try 10 to the power minus 2. A negative exponent. Just flip it, 1 over 10 squared, which is 1 over 100. See? Once you know the rules, exponents become way easier to simplify. Now let's decode fractional exponents. They look tricky, but they're actually super useful. Say you have 9 to the power 1 half. That's the same as the square root of 9, and that is 3. What about 27 to the power 1/3? That's the cube root of 27, which equals 3 again. So the bottom number of the exponent tells us which root to take. 1 by 2 is square root. 1 by 3 is cube root. 1 by 4 is fourth root, and so on. Just remember, fraction equals to root. What happens when an exponent is both fractional and negative? Don't panic, it's just 2 steps. Take 16 to the power minus 1 by 2. Step 1, the negative flips it, becomes 1 by 16 to the power 1 by 2. Step 2, the 1 by 2 means square root of 16, and the final answer is 1 by 4. So whenever you see a negative fractional exponent, first flip the base, then apply the root. Simple, right? Here's the best part. These exponent laws don't just work for whole numbers. They also apply to real numbers like decimals and fractions. For example, 2.5 squared is equals to 2.5 into 2.5, and that is 6.251 by 2 to the power 3 is equals to 1 by 8. So whether your base is a whole number, a decimal, or a fraction, the laws stay the same. That's what makes exponents so powerful. They work everywhere on the number line. Let's recap what you've learned. Exponents help us express repeated multiplication, roots, and very large or small numbers. You mastered the 5 main laws of exponents, Add powers when multiplying. Multiply powers when raising a power. Subtract powers when dividing. Flip the base for negative exponents. And apply powers to each factor in a product. These laws work for all real numbers, whether your base is a whole number, decimal, or fraction. You also discovered how to handle fractional and negative powers and even combine both. With these tools, simplifying expressions becomes fast, fun, and powerful. Up next, get ready to use these rules to compare and simplify real number expressions.